So let's take a look. I posted a video explaining the exam. I made a flyer showing you the results from all the different classes. Everyone did wonderfully. Most number of 100% I've had in many years. And some people, they weren't able to get it together in time to get that 100%, but that's okay. You have, what we're going to do is next Wednesday, and you read the flyer, yes? You read the message, I hope. If you have to retake it or you have to make it up, you have to come Wednesday night. I'm going to go over the test with you. Wednesday after school, not night, like 8 o'clock at night or something. Right after school, 3 o'clock, we'll go over the test. Should take about 20 minutes, okay? Maybe half an hour, depending on how many questions you all have. I'll explain whatever you need explained. It would make it a lot faster if you watched the video before you came Wednesday. So then you can come and we could just touch up any misunderstandings you have. If you don't, we're just going to have to go through it when you're here after school. So I would watch it and understand it as best I could on my own and then come in and ask questions. Really, that's really the key to success in college. It's key to success in high school and then college is that you do your best before class starts. You do your chapter reading before the test, before the teacher teaches it in class, so that you have some understanding of what's going on. Not after the teacher's taught it and you've taken the test and then you write down some gibberish on a piece of paper and turn it in as notes. That is not the way high school works. It's not the way college is going to work, okay? You read for understanding, you take your notes, then you come in and you pay attention, you ask questions, and you try to be as successful as you can. That's what studying means. That's what being prepared means, okay? I keep lecturing, I apologize. All right, so let's go over what we've talked about so far. We know the scientific method now, backwards and forward. And if we don't, we'll know it by Thursday, surely. So scientific method, we can check off that. At least we have a good understanding as we move forward. We're gonna do, everybody say hello. Let's stop class. Everybody say hello. Hi. All right, now we're all here. The scientific method. So we're using that in labs, all right, throughout the quarter, throughout the year. Secondly, we've gone over, different data, different types of data, right? And you may not remember that, but so let's go ahead and say it again. So we had categorical. We had, categorical, we had data that we need to find patterns in. All right, then proportional data or percentages, you might know it, percentages. So those were the three kinds of data we talked about. And of course, we've also talked about so qualitative versus quantitative, and we always want to stick to quantitative ways of dealing with as much as we can, because with quantitative we can graph it, with quantitative we can track it, with quantitative we can do mathematical analysis on it. So really we want to try to focus on that, okay? Anytime, even in psychology where you're talking about people's feelings, we want to try to make it as quantitative as we can. So scientists love qualitative. That's kind of our goal, our gold standard. If we can take information, even about people's feelings or how they react, if we can make it into some kind of series of numbers that we can adjust and seek patterns in, that's really useful. Qualitative is useful too, especially to try to inspire us to observe patterns in nature, but qualitative has limits that quantitative doesn't. Okay, so that's labs, and that's the scientific method. Does everybody remember everything, at least, that we talked about it all? Yes? That you got tested on it? Do you all agree? Right? Yes or no? Don't just sit there quietly. Yes or no? Okay, yes. All right. Jeez, it's like pulling teeth this morning. All right. It's like pulling teeth. I have to yank and answer. Come on. You can do it. Answer the question. All right. Scientific method, labs. All right, so now graphs. We looked at best fit line. We looked at a best fit line, and we said, look, we have data. How do we find a pattern in this? They're not lining up. And we understand at this point that most of the time, the data does not fit perfectly. Right? It does not. That's a no. Does not fit perfectly. All right? So we have to find some kind of best fit line, the best we can do to get as close as we can to the data without to each data point. Remembering that each data point is the fact, is the measurement. We measured this. It's a fact. Now, could something have gone wrong with that measurement? Yes, but that's a different kind of error. So today I'd like to talk a little bit about errors. Errors are expected. We're not talking about you making a mistake on a test. We're not talking about you choosing to go to a party instead of studying. Like that's an error, but that's not the kind of error we're talking about. This is not about you making a mistake during a lab. There's always going to be error. There's always going to be error. So I'm going to give you some examples in the real world that you might have experienced, or at least some of your parents might have experienced. You guys, does anybody here have a bathroom scale? Like, where your parents get on the scale, and they, you don't have a scale like that? All right, you have a scale. That's the point. Usually people keep it in the bathroom. And they get on it. I'm just going to put a square on here. They get on the scale, and let's say every morning you get on the morning and you weigh 90 kilograms. 90 kilograms in the morning. You go about your day, you're sitting down in chairs all day, you're drinking, you're eating, you come back. In the afternoon, you weigh yourself again. And now you weigh 110 kilograms. Did you just gain 10 kilograms worth of mass? What just happened? Did you get 10 kilograms worth of fat? Did you get fat in a day?
No, it's food.
It could be food. It could be water. It could be that the balance is adjusting. It could be that it's a humid day. It could be you're not wearing. There's all kinds of things that you're not controlling for. You have to control the different factors that might influence the measurement. Bless you. When you look at a driver's license, they tell you what your weight is. But the weight fluctuates during the day. water's heavy. And if you drink one of those big things of water, it's going to be heavy. So you can't look at a balance and tell a lot unless you're controlling for a bunch of different factors. And of course, are you on your period? Because then you're retaining water, right? Do you know that you retain water during your period? And different parts of your body swell up. Even though, your mother might be swelling up in her ankles, your aunt might swell up in her hips. My wife swells up in her hips and her back, and it pushes pressure on her, and that's what gives some people back pain during their periods, because they have that swelling pushes on nerves. Does that make sense? So the question is, how are you? That's heavy. That's water. That swelling is water, and that's heavy, and that's going to change this mass. So you have to control this by doing the following. You choose to measure yourself. Measure your mass. Let's measure our mass once a week. Why once a week? Because that way any daily fluctuations, because it'll be always daily fluctuations, you're not going to worry too much about it. You might be up an extra couple pounds today because maybe you drank some water, maybe you ate a lot of salt. Do you know if you eat salty things, you'll retain water? Did you know that? You'll keep water in your body instead of peeing it out. So if you're eating salty stuff, water, you'll retain. That's why you get high blood pressure, because your blood vessels get full of water, and that increases the pressure. So that's why salt is not necessarily the best thing for you. Even though you get rid of it quickly as a young person, as you get older, it gets harder. So eating a lot of salt may not be a good habit to get. That includes like hot chips, because that's a lot of salt. Look at the container. There's a lot of your daily in your. I think you have health. Do you not have health? One of the things you'll go over is the nutrition little sticker. It'll say daily allowance, percentage. And some of these chips, what does it say on your chips?
Come off of the sodium.
Sodium, what does it say?
190
Huh? 190 milligrams. What percentage of your daily allowance?
Huh?
Percentage of daily allowance.
On the bag?
Yeah, look on the bag. Here, let me see your hot chips. So this tiny little bag of hot chips, it says 270 calories. Your daily allowance for calories is about 2,000 if you just want to maintain. If you just want to stay the same way, about 2,000. Now you guys are probably a little higher because you're growing. You need more calories. So don't go by this number. I'm just saying on average it's 2,000. You guys are probably a little higher. You need 2,000 at least to maintain. Look, weight is just one thing. There's muscle, right? If you're too thin, your body will start eating itself. Did you know that? It'll start eating your liver and your gums. You'll start to bleed in your gums. Now I'm not talking about skinny people. I'm talking about people that are anorexic and bulimic. Does that make sense? It's okay to be thin. It's okay to be thicker. That's fine. That's nature's variety. It's fine. I'm talking about the extremes here. Are we clear? I don't see anybody in here that's anywhere near an extreme. Okay? So the total fat, in fact, I'm the one who's extreme. My body is extreme. I'm in what they call the category of obese. Okay? Obese just means 20%. I was morbidly obese. I was 600 pounds. So not too long ago. So let's look at the total fat. This is 18% of the daily value. Sodium, 4 of these bags is 100% of the salt that you can eat for the day, that you should be eating for the day. 4 of these little bags. Now add on to that your McDonald's French fries. Add on to that here's your chips. It doesn't matter. There's salt on them. I'm talking about the salt. Now all of a sudden you're eating you guys probably eat 2 to 3 times what you should be eating. 2 to 3 times, which means you're retaining water. Which means your mass, the weight The weight on that balance is going to be heavier than it would be. It's not fat, it's water. So water's very heavy. Fat is actually very light. That's why fat floats. It's not dense. Water is heavy. So that salt is holding you back. So, okay, once a week, then you can get some kind of measurement, some kind of estimate, right? If you do it week after week. So that's good. Then you have a routine. You want to make sure you have the same amount of clothes on, because clothes can be heavy, right? Wallets can be heavy. You could have jewelry, glasses. Now we're getting to a little bit of significance, but okay, you don't want to wear your glasses. However you're going to do it, you're going to do it the same. Keep everything the same. We're going to control all the variables. If you're really going to measure your weight, if that's important to you, really, honestly, weight is not the best way to track if you're getting out of shape or not. That's not really the best way because it fluctuates so much. But you do it once a week, and you get on this balance every morning on Saturday, like I do it on Saturday morning. And I measure my weight, and I don't really take it to heart. It's hard sometimes. Oh man, my weight went up, my weight went down. Okay, but I'm not sweating it. I track it. I put it in my health app on my iPhone, and I can show you the track, and it just tracks. Once a week, I put some dots on. And it goes up, and it goes down, it goes up, it goes down, goes up. Okay, but what am I going to look for? What does the iPhone do for me? It does what? What can I do with that data that I'm not doing here? That this doesn't help me. Does it help me to know if I'm gaining or losing weight overall? If I'm just going, my dots are going up and down? That doesn't really tell me much. So what am I going to want to do? Okay, I put the numbers down and then I plotted them. But what can I do to try to get an idea if I'm heading in the right direction or not? Draw the line, draw the best fit line, or what we call a trend line. So we draw the trend line, and we see our trend. And I'm looking and I'm saying, oh my gosh, overall I'm losing weight. Okay, I'm fine with that. This week I'm high, next week I'm low, but overall I'm losing weight at a steady pace, and I'm okay with that. And maybe at some point my graph will look something like, if I'm looking at my graph, it'll look something like, like this, and then I'll plateau. And then that's the weight. That's the weight. That's my standard weight. But will my weight actually be this straight line? Does data in the real world ever fit in a straight line? No. So my weight will actually do this. It'll just keep going up and down, but my goal is to keep that fluctuation within a certain normal range. I don't want it to jump up real high or go down real low. I want it to stay stable. Guys, it's the same thing with blood glucose. I'm diabetic, I told you. So when I look at blood glucose, if I know that the normal, the standard, the control group that I should be comparing my numbers to is a 100, blood glucose level of 100. When I stick my finger and I look at that machine, I don't want to see anything that a standard of much more than 100. I'm worried, and too far low, and I'm dead. I'll pass out at about 50. I'll pass out. That's danger zone. That's 70 is probably okay, but 50 I'm getting woozy. 40, I'm passing out. I'm going into a coma around 30. These are numbers I do not want to see. Is that clear? I see this. I know there's one thing I have to do. I have to eat sugar quick, and I mean candy. Has to be straight up Skittles. Yeah, it says pure sugar. I need to add sugar to my blood as fast as possible. All right. They have glucose tablets. They don't even taste sweet, but they're just pure glucose. You just put it on your mouth, boom, it goes in your blood. So I don't want it to get too high. If I get too high, I luckily am not at this point yet, but it could. If I get too high, I have to start to put insulin in. I have to inject insulin. I don't have to do that because I am not type 1 diabetic and I have it under control with other medication. So I'm able to keep my blood glucose around 100. So how do I do that? Well, what normally happens with most, is anyone else here diabetic that wants to volunteer their information? So no one here is diabetic, okay. So this, your grandma, you probably have uncles and maybe parents and grandparents that are, that's fine. Some of them might inject with insulin, and is also a necessary thing at some point. Look, African Americans, Hispanics, we have a higher tendency to have high blood pressure and diabetes. That's a reality. It's probably something to do with our genes, probably something to do with our lifestyle, all of it together. I mean, come on. Ethnic food is delicious, but is it really that great for you? You know, the salt, the fat, the sugar. I can tell you, Puerto Rican food, we make sugar in Puerto Rico. Like, we make it. Yeah, it's delicious, but is it the best for us? I don't know. But it's probably, that's a discussion you have with a nutritionist, but I'm just saying that's the way it is.
You should make some food and bring it.
I am. I'm going to bring a pork on October something. I know. Some of you guys don't eat pork. I'm sorry. But it's a thing we do. Puerto Ricans eat pork. Huh? For real what? Huh? I'm a big pig. And so a roast pig. It's not going to have the head. Please don't even say it. It's going to be a big pork. It's cooked with Puerto Rican seasoning, garlic, onions, and all the great stuff. And it'll taste delicious. You like pork rinds? Well, these are the real pork rind, which is the skin all toasty and delicious. Not a pig. It'll eat a pig that's cooked. I'm gonna bring a pig that's cooked. Yeah, I used to eat it when I was a kid, but no, I'm not gonna do that to you. I'm not gonna bring a full-on pork. I don't mind it. I do it. We've done, like when we have, look, Hawaiians, guys, Hawaiians. It's not even biology, bro. It's cultural. It's cultural. It's Hawaiian, Puerto Ricans. We cook an entire pig. We dig a ditch. We line it with all kinds of sticks. We burn it. We put the thing. We cover it up. We let it cook overnight. After we season the skin, and we let it cook. You ever see somebody turning a pork or that's or stuff like that? We'll do too.
We should make food.
Well, they're doing a Hispanic thing. For Hispanic month in October, I think they said October 8th. They're doing where all the Hispanic people are bringing foods for you guys. I think it's going to be selling it.
See, no, I'm saying like everybody in the class should bring it. Like
You want to do maybe Chris, maybe in winter break, okay?
yes.
I hope so.
Yeah, I'm bringing the meat. Like it's going to be the body. The meat's going to be on the bone.
You're going to bring a whole.
Do it. It'll get ate. It'll get ate.
Okay. So when you go to the store and you buy these things called, if you go to your parents' store, don't you?
Yeah.
And the Giant Eagle or whatever, and you go buy a ham. Did your parents ever buy a ham for Thanksgiving or for Christmas or winter break or whatever? That ham is a giant chunk of the pig. That's what it is. That's what ham is. It's usually the butt, the thigh. Well, that's what it is. How do you not know what you're eating? I do. It's delicious. So enough. You guys should know what you're eating when you're eating it. So anyways, if you don't want to eat it, don't. But you should know what you're eating. I mean, it's ridiculous to say, why are you telling me? All right, so if I eat Skittles, my blood glucose is going to go up. And naturally, what should happen is my insulin should kick in and it should come back down again. But because I ate the because my body produced insulin, and if I'm reacting to insulin correctly, I'll go under 100. I'll go low. And then I'll start here. At this point, I'm going to start to get tired. Notice that I'm annotating the graph. Notice that I'm annotating the graph. And some people are not drawing. So up here, I might feel a little hot. My skin might feel a little hot. I might feel a little weird, but I'm not going to be tired. But down here, I'm going to be tired. And then as I start to get tired, I might eat something, or I might, do anything else to start to bring what will happen is my liver will release sugar into my blood because I got too low, and the sugar brings my blood glucose up again, which then means more insulin has to go in, and it'll bring my blood glucose down. And then my blood glucose will have to go back up again. So normally what happens is your blood glucose goes up and down. When you have big meals, it goes pretty high, not too high. If it gets all the way up here, now you're in danger of strokes, of having all kinds of bad things happen. Your blood pressure is going to get real high. There's going to be all kinds of bad things that happen. Your blood gets sticky. It's harder to pump, that kind of thing. So what happens is that if you connect the dots, what happens is you'll get blood glucose doing something. Your blood sugar is going to do something like this. It's going to go up and down. But it's going up and down around what? Around 100. And it's not going way too low. It's not going in danger zone. This here would be the danger zone. It's not getting into the danger zone. If it gets in the danger zone here, this is acute, which means it's an immediate emergency. You're going to the hospital because you're in danger. You're in a coma. You're passed out. That's what happens if you get too low. If you get too high, it's also danger because what happens is that your blood pressure gets so high that you're in danger of a stroke or some other the thing is you don't even know it's too high. You can't tell it's too high because your body doesn't react the way it does when it gets too low. But it's not an acute problem. This is chronic. So this problem up here, too high, is called chronic. And down here is acute, meaning it's an emergency, an immediate emergency. But no, you guys probably keep your blood sugar around here if you're not diabetic, which is fine. That's normal. Which is, by the way, when you give a kid candy, it doesn't make them hyper. People tell that's a myth. What happens is you give people candy, the kids are going to start feeling a little weird, a little hot, and then they're going to crash. It's called a sugar crash. Because what's going to happen is they're going to release insulin, their blood glucose is going to go real low, and they're going to want to go to sleep. That's what happens. Hispanic mothers know this. That's why they give two things. They used to give me and all my siblings and everyone where I came from in our bottles, in our baby bottles. They used to put coffee and sugar in a baby bottle and milk, obviously. I don't know if it's okay or not, but that's what they used to do. They used to do a lot of stuff when we were kids, but they would put sugar and coffee in our, and they knew what would happen instinctually just because they've done it. You tell someone today that you gave a baby coffee, it's like, what are you, crazy? You're going to try to keep the baby up all night? No, coffee to children, to a lot of children your age and younger, coffee will do the opposite it does in adults. Instead of waking them up, it puts them to sleep. Is it good for them? I don't know. I'm going to say no. Don't give a baby coffee. I'm just telling you what they did to us. They'll give you coffee and you're going to want to go to sleep, and then the sugar, like I just said, will make their sugar drop, and it's going to want to put them to sleep. So babies would go to sleep more often with coffee than not. Then when we become adults, our bodies change, and our reaction to coffee is it wakes us up. We know coffee is good for you, by the way, for adults. Unless it makes your heart race, the caffeine makes your heart race, we know coffee can extend your life by 10 years. Has a lot of good antioxidants in it. It's not true that coffee makes you stunt your growth. It's not true a lot of the things they say about coffee. It is true that coffee can make your heart race. Like my nephew can't drink coffee because his heart will start to pound. He reacts to coffee, the caffeine in the coffee, in a different way than the rest of us do. But if you don't react that way, it's probably a good idea to have coffee. Now, what's the negative is when people put a lot of sugar in it, because now you're making it unhealthy. So when you drink a frappuccino, or a lot of this stuff in Starbucks, if you look at the diagram, at the chart, there's a lot of sugar in it. I drink black coffee because I like it. I've always drank black coffee, but I also drink it this way because I'm diabetic and I'm not going to drink sugar. I'm not stupid. I don't want to die. So there it is. That's how graphs can help us understand what's happening in our bodies. And again, when we're talking about mass, there's going to be error. This stuff here, these fluctuations, these are things that means that we cannot keep. You can't trust the numbers you're looking at. There's what we call variation. Variation in the data. We expect that. That's nature. There's a million reasons why. A million. But we expect variation in the data. We expect the data to go up and down and be all over the place. But overall, we expect there to be a trend. The trend could be flat. It could be stable. It could go up and down like this. It could go straight down. It could go down and then flatten out. A lot of things can happen that are natural and normal. Some of it would be real bad for you. If you see a trend where you're like, you're in the emergency room. If you see a trend where your blood glucose is up here and it's flat and it's chronic, you're talking going blind, losing a foot, that's what's going to be predicted, what's going to happen to you if your blood glucose is this high for that long. Does that make sense to you? So tracking the data and trying to deal with this variation in the data is this whole that's what statistics is about. Trying to figure out how do we look at all these measurements and make some sense out of it. And then the last piece that you need to think about is this error business. And here is, when I measure my blood glucose and it says 60, is it actually 60? I can take my measurement and I can take my measurement of my blood glucose and it can be 60, 65, 63, 62, 60, 61, 70, 62, 61, 60. Which one's correct? I don't know. When I go into the doctor, they'll put a cuff on my arm and the machine will start to measure my blood pressure. They'll do it 4 times. And all 4 times the number's different. Which one's right? We don't know. We just have all this data. What do we do? What do they do when they measure my blood pressure 4 times? What do they do to try to make an estimate of what my blood? It's an estimate of what my blood pressure is. What do you do with three data? Let's do it because you guys need. Yesterday you told me you couldn't do it, so let's try. Yeah, that's right. We do an average. Limits to the accuracy of your measuring device, and you have limits to the accuracy of your data because of fluctuations in the environment. So we try to deal with that by drawing the best fit line, by looking for patterns, and then deciding what ranges are healthy and what ranges are not. So when we look at blood pressure, we say anything over 140, right, is probably not good. 120 is okay. 140, anything over 140, we're kind of in the danger zone. If you're at 200, now we think we need medication. Anything higher than that, blood pressure-wise, we're really concerned. Same thing with too low. Too low leads to passing out, leads to comas. You can't have blood pressures too low. It's the same problem with blood sugar, right? So you need to have things that you have to address in that form. Everybody okay with that? All right, let's go on. So if we were graphing that data, we would draw the best fit line. But since then, we're not going to sit there in the doctor's office and start drawing X and Y's and start plotting points, right? What we can do is we can say, okay, my blood glucose is 120, 125, 130, 110. All right, so which one's correct? I took this data, the machine took it 4 times. How do I know which one's correct? Well, I don't know which is accurate. Accurate is something that is accuracy is we'd have to know the actual answer to measure. But it's within a range, right? We know the range is from 110 to 120. We know that that's the range. So we're probably the right answer is somewhere in there probably. So how can we get a number that we can put down on paper that for this doctor's visit, this was my blood pressure? I could take an average. And you guys could not take an average for yesterday for extra credit, right? You guys said you couldn't do it. So let's do it. So these are 4 trials, 4 times. So what do we do if we're taking averages? Anybody know? So to take the average, we add them up. So we got 5. We have 4, 5, 6, 7, 8, and 1, 2, 3, 4. 485. And then you divide, so you sum, this is the sum, right? You take the average of these 4 numbers is first, add all the numbers together, all your values. Second, divide by the total number of samples. How many samples do we have? 4. So 485 divided by 4 equals what? Do it. Y'all can divide by hand, right?
No.
You can't. You've never divided by hand? Wow, you guys can't divide by hand. You guys, wow. So 121.25. So the way you divide by hand real quick is take 4, you put the little 485 in here. 4 into 4 is 1. Bring here to 0, put down that 8. 4 divided by, 4 goes into 8 2 times. That's 8. Subtract those 2, that's 0. Bring down the 5. 4 goes into 5 1 time. That's 4. That's 1. Bring down, you put a decimal, put a 0. That's 1. 4 goes into 10 2 times. That's 8. That's 2. 4 goes into 20. How many times? 5 times. So that's how you get the number using the long division. But we'll do more averages. That's how averages can be helpful, right? Trying to adjust for errors. Errors that machines make, errors that are naturally part of the experience of being human. Not an error that the doctor or the nurse is incompetent. It's not time to go yet. I still have to take attendance, even though I let you guys pack everything away. 100 if I